Hi everyone, this is Mona. In this video we want to cover the naming of ionic compounds. So the things that would be covered in this unit would be how to name the ionic compounds, how to write their formulas, talking about the different polyatomic anions or cations that we might have, in which cases we use the term ide, ite, or ate, and then about hypo and per, which is in some of the polyatomics we notice that they come at the beginning of the name, so we want to talk about all of this in this video. So ionic compounds are usually made out of a metal coming with a non-metal or a metal coming with a polyatomic anion. So for the first case we have like sodium chloride, so sodium comes with Cl, which is a non-metal, or we can have KNO3, like potassium coming with nitrate, which is a polyatomic anion, and same thing for iron hydroxide, iron 2 hydroxide, like iron, which is a metal, is coming with the hydroxide, which is a polyatomic anion. So in general, metals get a positive charge. Polyatomic anions or non-metals, they get a negative charge. So here is a few possible cations that we can have. So they can either be polyatomic, like NH4+, meaning they can have multiple atoms in them, or they can be monovalent cations like Ag+, sodium+, which means they only have one charge and they cannot have any other charge other than these. And then the last case would be multivalent cations like iron, for example, that has a charge of +2 and +3. So we have these are the possible anions that we can have. Again, they can be monoatomic anions, like meaning one single atom in them, like S with a charge of 2-, nitrogen with a charge of 3-, or they can be polyatomic again, which are made out of multiple atoms, so like NO3-, PO4, 3-. So in general, if we have a periodic table, in terms of charge, we can give the rule that for metals group 1, they always get the positive 1 charge. Metals 2 get the positive 2 charge, and then metals 3, they get the positive 3 charge. Group 2 is kind of in between, so they can become minus or plus both, so we don't want to focus on that much. Group 5 in general gets a charge of -3, 6 gets a charge of -2, 7 gets a charge of -1, and then 8 has usually no charge. And that is because if you think about it, metals, they tend to lose electrons, so they get a positive charge so that they can look like the last noble gas before them. So this way they'll become very stable. And on the other hand, nonmetals, they tend to gain electrons so that they can become more stable and they can look like the noble gas coming after them. So the whole point of chemistry, the whole point of forming compounds, in chemistry is because atoms, they want to become more stable than what they are. So that's why they are involved in bonding and everything. So, and then when we get to the cases of the transition metals, usually transition metals, they have multiple charge. Again, there are exceptions, like silver having only a positive 1 charge, or like zinc having a positive 2 charge, but most of them, they have multiple charges. So when writing the naming, we have to mention the charge for sure, and I'll explain that after. So here is how we can write the formula of an ionic compound. So what we do is, usually when you have sodium, like with the charge of +1, PO4 with a charge of 3-, what we do is we cross their charges. So we write the charge of sodium basically underneath PO4 and the charge of PO4 underneath sodium. We don't use the minus at all. We're dealing with positive numbers, so this is like a ratio, like how many of each we do need in order to balance the whole charge. So as we can see, PO4 3 goes underneath sodium, and then sodium 1 goes, the 1 for sodium actually goes underneath PO4, so the compound turns out to be Na3PO4. Same thing for the next one. Mg has a +2, nitrogen has a charge of -3, so if we switch the charges, the compound would be Mg3N2. Next case is iron +2 and OH -1, so again, if we cross the charges, it will be FeOH2. Last case is calcium 2+, oxygen 2-, so if we switch the charges, basically what happens is that because they both are 2, we end up canceling them. So basically you have to note that when they are, like, if they can be canceled, that we actually, in ionic compounds, we always cancel them. This doesn't apply to covalent compounds. I'm going to give you another set of videos for naming of covalent compounds, but for ionic, yeah, if we can cancel them, we do cancel them. So this is the case. You might be wondering when to use the ide, ite, or ate. So when we're dealing with the monoatomic anion, basically, what happens is that the charge, the name of them changes to ide. when they're polyatomic, depending on the number of oxygen they get, they can be ite or ate. For example, this the below example is for nitrogen, when we have nitrogen alone, or nitrogen coming with 2 oxygens, or nitrogen coming with 3 oxygens. So when nitrogen is alone, the name is nitride. When it has 2 oxygens only, it becomes ite, and then when it has 1 more oxygen, it becomes ate. So basically, first case is for single atom of nitrogen, which we get the ite for. The second one is the oxide of nitrogen with the lower subscript, and then the next one would be the oxide of nitrogen with the higher subscript, basically. Same thing for sulfur, sulfite, and sulfate. If we notice, S alone would be ide, SO3 with a charge of 2 minus would be ite, and SO4 with a charge of 2 minus would be ate. Another example is the case for phosphorus. Phosphorus alone would end up being phosphide, PO3 with 3 minus, meaning less number of oxygens would be phosphite, and then PO4 with a charge of 3 minus, having more oxygens would become phosphate. Here we can have some examples, try some namings and see how we do. So for the first case, we have sodium nitrate, very straightforward, and keep in mind that when you're writing the namings, for metals, if they have only 1 charge, they're monovalent, you don't need to mention the charge. So this is the case for sodium, for example, you don't need to mention the charge. And then nitrate, NO3 is always nitrate, so you just write it as sodium nitrate. For the second case, iron is multivalent, meaning it has multiple charges, so I have to mention which charge of iron is being in this compound, so I have to say iron 2 hydroxide. Third case is potassium. Again, it has only 1 charge, so I don't need to mention the charge, potassium phosphate. Next case is vanadium, which is a transition metal, has multiple charges, so I have to mention the charge. So because the charge of vanadium is actually written underneath oxygen, I know it has a charge of +5, so I have to mention vanadium 5 oxide. Next case is magnesium carbonate. So magnesium has only 1 charge, we don't need to mention it. And then last case is potassium permanganate. So same rule. This is the description. This is exactly what I explained right now, so if you want to go over it one more time, go ahead. This is just for the ones that they don't like to listen to my voice and they just want to read the notes. I have written everything down basically for you. So now there is cases that when there's oxides of different anions like ClO, ClO2 minus, ClO3 minus, and ClO4 minus. See, there's multiple number of oxygens, so we don't know how to name these. So basically the rule is for the middle 2 ones, like ClO2 minus and ClO3 minus, we treat them as our regular like ite and ate case, like chlorite and chlorate. Now when it gets to ClO minus, it has 1 less than the chlorite, so it's going to be hypochlorite, meaning 1 less. And then for the ClO4 minus, it has actually 1 oxygen more than ClO3 minus, so we call it perchlorate. So again, this is how I explained it, just in text. And same thing goes for Br case, the oxides of Br, so it can be BrO minus, BrO2 minus, 3 minus, and 4 minus. So the middle 2 would be the regular case of bromite and bromate. BrO minus would have 1 oxygen less than BrO2 minus, so it would be hypobromite, and then BrO4 would have 1 oxygen more than BrO3 minus, so it would be perbromate. So just to wrap it up, here is some example for more namings, which includes this multiple number of oxygens in the polyatomic anions. So for the first case, we're dealing with ClO4 minus, so that's going to be the case of perchlorate, so it's going to be sodium perchlorate. Second case is magnesium, again the highest number of oxygen for Mn, so it's going to be permanganate, so magnesium permanganate. Third case is iron, coming with a charge of 3, so we mentioned the charge iron 3, and because it's ClO2, it's going to be the chlorite case. Next one would be nickel, coming with a BrO3, which would be the bromate case, so we have nickel bromate. Again, nickel is a transition metal, but because it only has 1 charge, we don't need to mention the charge. The only charge that nickel can get is actually +2, so we don't need to mention the charge. Okay, I hope you enjoyed this video. Thanks for watching. See you guys later. Thank you.